This is the second video in how to write a desktop app that can interact with things like social media and remote storage via a RESTful API. I wanted to interact with DropBox, so I looked into the documentation, and it described how to use their published endpoints using a command line tool called curl, which I didn't know about and not used before. So I looked into that, and it resulted in a desktop app, dialog based, written in C++ using the MFCs, that uses libcurl, which in turn needs to use OpenSSL. And as well as that, I also use Intel's thread building blocks to schedule work over all available cores, and I also use Boost to parse the JSON that's returned from DropBox. So my starting point really was looking into curl, this thing I was reading about in the DropBox help, and it looked well established. So I downloaded the latest libcurl from hacks.se, then built, there's a solution that you can use to build for Windows, so start off there, look in projects, look in Windows, VC15, and then I built that, and the configuration that I used was no dependencies and static lib and in debug. So that built me a curl that I could use at the command line. So I followed the instructions from the DropBox help, but it didn't work, and it was complaining about no HTTPS support. Looking into that, I found out that you could use another libcurl build configuration that also uses OpenSSL. So again, OpenSSL is something that I'd not heard about or used before. So found the latest version in GitHub, basically followed the instructions off of a video by a channel called Troubleshoot, which is really good and really easy to follow. You basically have to get the latest from GitHub, OpenSSL. You also need Perl, which I use Strawberry Perl, and you also need NASM from nasm.us. Once you've downloaded and installed those, you set up a build environment so they can be used on the command line. Start up an instance of your 64-bit Visual Studio 2019 command prompt, tools command prompt. Download and install a couple of Perl modules that you need, text template and test more. And then I browse to the OpenSSL folder that's got the configure in it and ran perl configure --debug because I wanted debug, vc-win64a because I wanted 64-bit, a couple of folders that I'd created, one for the output that I wanted, one for a temp folder, and also no shared because I wanted a static lib. I then ran nmake test followed by nmake and nmake install _sw. So that resulted in me having a folder of OpenSSL include files and OpenSSL include libs. Went back to my libcurl solution and created a couple of property sheets that pointed at those OpenSSL files that I now had, the headers and the libs, and rebuilt curl with SSL support, OpenSSL support, and then again entered the curl command line operations, and everything worked fine. So I now had the libs to upload to DropBox, so that's a good starting point. I had my dialog. I'd created an owner draw list control. I don't think there's any real need to go into that because it's pretty standard how to create Windows owner draw controls. the only real work started when I had to start using libcurl. The append button, all it does basically is populate this list control, so start is the start of the actual work. So if we have a look, this is my start handler. And before we look at that, actually, Intel thread building blocks and libcurl need to be initialized and stay initialized throughout the lifetime of the app. So I created a global curl, which all it does is call its global init in its constructor and its global cleanup in its destructor. And if we have a look in the app, the header of the app, there's an instance of, there's a declaration of that global curl. STL is used throughout the app for things like pointers, containers, vectors, sets, maps, and so on. And also the scheduler, which I needed for thread building blocks, that needed to be instantiated at the beginning of things as well. So in the constructor of the app, we basically set up curl and set up thread building blocks to be usable for the duration of the app. When the app goes away, the ref count of these ref counted pointers will make sure they get deleted, and in their destructors they call the necessary cleanup code. So let's go back to on start. So this is me presenting the user with that authorized dialog that they can then copy to a browser and validate access to their account and return back a code. That's the code that gets returned back, and I pass it to this token request. The idea is that we end up with a Dropbox access token. So if we have a look at upload, this is the call that we make. This is the call command line. This is the curl command line prompt that we're trying to programmatically replicate. So you have to establish a connection with curl, which we do there. Curl's designed to be reusable, so you can, if you want, pass something in and use that. I don't. I always create a new connection with each request. And curl likes the fact that things can be reusable, because obviously it's got benefits. But I like to reset it, reset the curl handle, and effectively start again. So you have to set up curl using various options. There's two ways of using it. There's the easy way and there's the multi-way. Multi is more to do with non-blocking multiple calls, or non-blocking single calls that you want to not be hanging around. You don't want to block that thread. Easy is, as its name suggests, easy to use. So we know the URL that we're after using. It's API, dropboxapi.com auth2 token. So we give that to curl. We know that the post parameters, the post fields are code equals something and grant type, which we've got the authentication code from that dialog that the user's given us. We then set up grant type as authentication code, and we, like I suggested, like I said in the previous video, when I registered the C++ app in the Dropbox App Center, it returned back a key and a secret, and you then give that to curl as well, using set option, username and password. I also used the certificate to verify the peer that came with libcurl. If you don't have to, and if you don't want to, you can just switch it off. Now curl allows you to set up some callbacks. So we set up a write function callback, and the write function callback will use this parameter, will be given that parameter there. So that function will write the result into that string. And like I was saying previously, using the easy perform is a blocking. I think internally it uses the multi interface anyway, but blocks and waits for it to return. So we've mirrored this command line, we've called perform, and we have the result in that string which we store there. We go back to the dialog and we get the result that we've just seen from the request, pass it to the Json parser. The Json parser is not really that interesting to look at. It's just a simple class wrapper for Boost's property tree. Hopefully we're looking for an access token being given back to us in the JSON code block. And now we've got the ability to interact with the user account. We know that we allow one of 3 upload types. So I set up the upload type that we want, and then we get the uploads. All that is basically doing is getting the selection, or in the case of no selection, I interpret that as upload everything. And then we can start, because we've got everything there. We've got the uploads that need to happen, we've got the access token, we've got the type, the style of the upload, and this is the scheduler that's required if we use thread building blocks. So that's going to start the thread, and if we have a look at the thread in its instance here, it checks the type that it's been given for parallel and serial. Parallel and serial are really the same thing. It's just that the chunk of data that they've been given to do, in the case of parallel, will be 1. In the case of serial, will be greater than or equal to 1. And it repeatedly calls another request. Requests are effectively wrappers for curl options being set and calls being made and return values being fetched. This one I've called upload file, so we know the files that we need to upload, so let's just repeatedly do them. And if we have a look at this one does the real work. Again, in the DropBox documentation, which is really good, it shows you how to use curl on the command line to perform an upload. So all you need to do is programmatically replicate that. So again, we create a curl connection, we open up the file that we want to upload, get the size of it because we'll need that later. I reset the options and then start trying to replicate this. I say verify peer is true again, so I use my certificates. So we set the URL to upload because we know that. We need to set up a header, so that's the header that we need to set up. The bearer, the API, the API arg, and the content type. So this is us doing that. This is done via curl's slist. So effectively we just set up an slist, instantiate it with the strings that are needed, and we'll use that later. So these are the options that we use. So we set up curl to do an upload. We want a read function. all the read function is going to do is use that file that we opened previously that was hopefully a success. It gave us that. So we have a read function that will be passed the file to read from. We have, like the one that, like the previous request that got us a token, we'll have a write function to get the return value. This is the slist that we previously set up with the header strings, and then we now give that to curl. Also interested in getting some progress feedback from curl so we can give it to the user. So we have another function, callback, that we set up, transfer function, and we give it progress, which is basically the upload that's happening and the thing that's interested, the window that's interested in notifications about the progress. And we tell the curl as well about the size of the thing, how large the upload's going to be, and also it needs to be a post, so you need to set up the custom request. So we've set things up now, and now again we call perform, which is the blocking transfer, so after that we tidy up the slist, we close the file, close the connection, and we have the result here. I also set up the progress to be 1, so it's definitely the user can see 100% that the upload's finished, and then we've got our result. So if we go back to the thread, one thing that is the handler for parallel and serial. One gotcha that got me was I started to see memory leaks when I was exiting the app, and that's because I did find a discussion about the memory leaks in libcurl, and they spoke about static builds only, because DLL builds will have their unload function called for the DLL, and in the unload it calls this tidy up for OpenSSL, whereas we wouldn't for a static lib build. So I call it manually. Basically, if you're doing any work with libcurl that is also using OpenSSL and it's in a thread other than the main thread that you've globally set up, libcurl, you need to call this or you'll see memory leaks. So the last thing really to discuss is the multi-core version. Now the multi-core version, I've written a little thread building blocks class that you give it a task and it then spreads the work, the size of that task, over all the cores available. In this case, the task that we're gonna instantiate gets given the upload, the access token, and the window that's interested. Basically mirroring this, but in the parentheses operator for the task. So say for instance there's 10 uploads and there's 4 cores. One instance of this may be given from 0 to 2 or something. So you iterate over the work that the core you're currently on has been allocated to. So you iterate over the work that the core that you're currently on has been allocated to, and it's just a mirror of the file upload request, which was called for the parallel and serial version. Again, when we're in here, we're in a thread other than the init instance of this. When we're not in this thread, we're in a thread that's in a thread pool that's maintained and handled by thread building blocks. So again, just like we tidy up here, when we exit this thread, so the work that this core is doing has done, we tidy up there. So that's the class that does the actual work, and then the call to schedule the work over the available cores is this parallel for. So when this call is made, we are actually in this thread, but this call blocks, spreads the work using this task class over all available cores. So when we're in here, we may or may not be in the calling thread. So that's and there's various other bits to handle cancellations and so on, but that's kind of the gist of it. And then when the thread's done, it posts a message to the notification window to tell that it's done. All that does is goes to the main app. The main app has a map of threads, and it will then come in here and effectively tidy this thing up. And that's all there is to it, really. So interesting things are learning how to build and use libcurl, OpenSSL, and use them successfully in a desktop app to interact with a RESTful API, in this case DropBox. Don't think there's anything else, other gotchas or any other difficult things, so I shall leave it there.